who haven't heard of Bitcoin, I'll be talking about what it is, how it works, what is Bitcoin wallet, what are miners, and how to get some Bitcoins. So pay attention. So what is Bitcoin? Bitcoin is a 100% digital currency. There is a limit to how many Bitcoins there are in the world. The guy that programmed it limited to 21 million. At the moment, there are 13 million Bitcoin that's already been mined. There are no central bank that controls Bitcoin. For example, in the US, if the US wants more money, they just go to the reserve and they just print money. But with Bitcoin, people have to mine for Bitcoin, and there's no central authority over Bitcoin. It works through P2P, peer-to-peer, so it's a group of computers mining Bitcoins together and verifying transaction. And all transactions on Bitcoins are public. So when I send money to Jeremy, that anybody can see the transaction, except that they won't know it's Jeremy or me. There are two different types of Bitcoin users. The first one are the power user. They are called miners. They mine for Bitcoins and they verify transactions. The second are regular users, the consumers, the investors, and the merchants. The consumers are you guys who want to purchase, say, a pair of shoes. You can use Bitcoin to purchase shoes. The merchants are the sellers who sells and receives Bitcoin. Investors are people who are very curious, like his daughter, about investing in Bitcoin, buying and selling Bitcoin when it goes up and down, because the price fluctuates just like any currency. And for you guys, if you're interested in using Bitcoin, the only thing you need to get is something called a Bitcoin wallet. There are different types of Bitcoin wallet. There's 3 ways you can get a Bitcoin wallet. You can have it on your desktop, you can have it on a cell phone, a mobile device, and you can use it on a website. There are websites that provide Bitcoin wallets for you. And there are pros and cons to using those 3. And this is an example of a Bitcoin wallet on your cell phone. It looks similar to kind of your bank statements. You see the past transaction, your balance. This is your options to send or receive Bitcoin from other users. It's very simple to send Bitcoin. You just need their Bitcoin address. And this one is Coinbase, so you can actually send it to someone's email. But if you want to be anonymous, you want to use a desktop wallet instead of Coinbase. And this is a sample transaction of 500 Bitcoin. That's a lot, by the way. So you're all running, wow, Bitcoin's great. It's $600 per 1 Bitcoin. So how can I mine some Bitcoins? You guys want to mine some Bitcoins? All right, so to get Bitcoins, there's 2 ways to get it. One, you can buy Bitcoins. You can go to Bitcoin exchanges such as Bitstamp or BTC Exchange, and you give them real US dollars, and they'll send you Bitcoins to your Bitcoin wallet. Investors, they do a lot of buying and selling of Bitcoins to make real money. Second way is you can become a merchant. You can offer accounting services or selling your old computers, and you can accept Bitcoins from other people through your Bitcoin wallet. And the third way to mine Bitcoin is for the power user. Basically, you get Bitcoin for verifying people's transactions. So those are the 3 ways to obtain Bitcoins. And now let's talk about the power user, the miners. I know you're all interested in mining some free Bitcoin, right? All right. So what is a miner? What a miner does is very complicated. There's a lot of math behind it, but we're not going to go into that. It's too complicated for you guys and for me, except for Miklos. But they use and pay. They use special softwares to solve special math problems. Basically, they're feeding functions random numbers, and when they finally found the answer, then you get the Bitcoin. And the more miners in the system, the better the system will be. Without miners, there will be no Bitcoin. The system just wouldn't work. So now you're saying, all right, that's awesome. So how do we become a miner? It's pretty simple. You just need 2 things, the software and hardware. Software is free. So that's the easy part. This is an example of a mining software. All you have to do is install it on your computer, press stop to stop mining, and start to start mining. And your computer just chug it out mining Bitcoins for you. There's no manual work. So it's easy. But the hard part, it's going to be the equipment. Your computer right now can mine Bitcoin, but it's going to be super slow. It's like a very inexperienced miner going inside a mine mining for gold. What you will need is build a computer specifically just for mining, or you can buy a mining hardware. This one costs $1,200. The next thing you're going to need, this is a more complicated miner, and more expensive too. The next thing, these are ASICs miners. They're hardware specifically built to mine Bitcoin. And this is a USB that plugs into your PC, and it uses all these hardware.
They are chips.
No, they're chips. They're hardware specifically for mining. It's like think of a graphics card that you plug into your computer. I think they sold it. When the feds raid people and they have Bitcoin, they just sell the Bitcoin. They auction it off. So this is a very complicated graph on how Bitcoin works. So I'm going to put it into 5 simple steps. So the first step, say, I want to send money to Jeremy. I just put in Jeremy's Bitcoin address, and I sent the message to the world that I am sending Jeremy 5 Bitcoin. But they don't know who we are, but they know that the transaction is happening. So when that happens, I create a signature and a public key. The signature and public keys are public. And this is where the complicated part comes. The miners are trying to match the public key with the signature. If it matches, then it verifies that I have that 5 Bitcoin to send to Jeremy. And it does that through very complicated math, and that's why you need a very powerful computer. And this is where the mining happens. And after it's verified, then that 5 Bitcoin will show up onto Jeremy's Bitcoin wallet. And so now you're saying, no, I got all this Bitcoin. What do I do with it? Well, you can buy a car. You can buy some shoes. You can buy anything from Amazon. Basically, what I'm trying to say is a lot of big companies are accepting Bitcoin. So that is why a lot of people are interested in going into and mining Bitcoins and investing in Bitcoin. And there are some downsides to it. Well, the advantage of Bitcoin is because it's anonymous, and it's a double-edged sword because since it's anonymous, a lot of bad people want to use Bitcoin as a way to launder their money because no one would know who you are.
My name is Abdullah. Like Professor said, I'm a third-year PhD student in the Accounting Information System program, and my current research dissertation is centers around the topic of data visualization. So this is just an overview presentation. I'm not going to go much detail like Professor Isa did, but a quick glance at the agenda, just a quick introduction, and then what is data visualization, why it's useful, why we should use it, and the benefits of data visualization. And I'm going to quickly go over some examples of data visualizations. So as we know, we have many forms of data emerging in terms of photos, videos, voice. When we take using our smartphones, and also we have in social media sites such as Facebook and Twitter, and also emails. So basically, what's happening now is businesses are so overwhelmed with the amount and variety of data that they're that's cascading in their business operations. So as Professor Isa mentioned, that some kind of information overload is occurring in these businesses. So such big data, or which is a term like which we use that describes complex and diverse data sets, is emerging. So companies are trying to come up with deeper and faster insights into how to come up with better decisions when dealing with such huge data sets. So one way of dealing with these issues is using data visualization. So what is data visualization exactly? So it's basically the process of converting this raw data sets or this raw data that we have into some sort of visual form, where we allow the humans to get insights, to draw conclusions and hopefully come up with better hypotheses. And the main objective of data visualization is to integrate the human in the data analysis process. It's not just you get results and you just read them. The human needs to interact with the visuals. So why we need to do that is because humans have their perceptual abilities, they have the flexibility, the creativity, and also general knowledge, and which will help them ultimately when they look at these visualizations. So why do we use visualizations? The human visual cortex dominates our perception, and we have more than 20 billion neurons in our brain that specifically devoted to analyze information. So basically, we are like a pattern recognition machine. We are born to detect patterns in using our eyes. So, and especially with today's advancements in hardware and software and the computational power we have, we can go one step further and know that humans alongside machines are much better than just humans alone or machines alone. So, just summarizing the benefits of data visualization. Like I said, since we have now big data sets, data visualizations can easily deal with such diverse and huge amounts of data. And another benefit, or an important benefit, is that it's intuitive. It's less sophisticated. It doesn't require heavy mathematical, sophisticated mathematical statistical algorithms to actually visualize some graphics. Also, it allows for faster exploration. So when these companies have huge data sets and they just want to gain some knowledge, understand what they're dealing with, so it's very good in basically data exploration. Just get an idea of what the data, make sense out of it basically. And also it helps in noting exceptions. Like I said, we are pattern finding machines. Our eyes help us detect patterns. So any exceptions in these visuals, we can easily detect patterns. And again, it also, when you see the data in a visual form, you can get different perspectives of the data and not only detect exceptions, but just see it in a different perspective. Let me give you a quick example. So let's say we have this data set, and again, this is just an example. In a company, it would probably be tens and thousands of times larger. But let's say we want to write an algorithm that would tell us the number of sevens in this data set. So if we just did this, an example would be like the count would be 5. We have 5 sevens, and the location, column 2, row 3, column 2, row 5, etc. So this is one way of getting the answer. Another way would just simply to just visualize in the simplest form is just to color the number sevens. Here you can just see that we have count them 5 sevens, and not only this, but like I said, in one of the benefits is you get a perspective of data. So you can notice that there's some kind of trend that all the sevens are located in this side of the data set, but we have one here. So is this an outlier or not? If we write just a simple algorithm, just will give you the results. Maybe it wouldn't give you a perspective as we see now. So that's one of the benefits. So again, what visualization does, it leverages the abilities of our eyes and perception, and helps us in detecting these patterns. So this is another example. So how many pattern violations can you detect out of this? 6? Actually, there are 7. So let's look. So we have shape, we have some kind of blur, we have size, color, which I showed you in a previous example, position, and skew. So these different different violations in the data sets, our eyes can easily see. If this wasn't visualized, maybe you guys would have said maybe 1 violation, but just visualizing, yeah. Skew. Oh, sorry, it's 6 actually. Yeah, 6. So yeah, you were right in the. Yeah, so you guys were right. The 6 exactly. Yeah. So again, having visualizing data sets, using our eyes, we can easily detect pattern violations, whether in terms of trends or different gaps or outliers. So that's one of the benefits of data visualizations. Let me quickly go some of the examples. Most of these, if not all of are examples we actually use in our research. So this is one of the simplest forms of data visualizations, just a simple bar chart, which is basically representing data points in terms of rectangles, where they have the lengths proportionate to the values, And again, it helps you in looking at seeing trends, maybe seeing outliers. One bar is like shooting way up there, so that's probably a question mark. Why is this so high? Another example is a bubble chart. So bubble charts are basically data points represented as bubbles, and you can have like the size of the bubble representing like for example dollar amounts, and you can also have like color representing like other attributes. Heat maps is maybe one of my favorites I use. It's basically kind of a matrix where you present data points, and it's basically it represents multiple attributes. So you have the size of the box, maybe representing like a dollar amount. The heat intensity or the color intensity of the box represents maybe the amount of sales. So here this is one example that we actually use in research. So we see that starting from here we have a company that has high amount of sales and high amount of dollar amounts, and then going back you can see it kind of shades, goes low, but one kind of an outlier here, Staples, where they sell high dollar amount and but they don't. I mean, they said high sales but low dollar amount. So kind of question mark, is this normal behavior? So it kind of helps you understand the data. Just visualizing it, looking at the table. This is like over almost 1 million transactions. So just there's no way in just looking at this and row by row. So like Professor said, in this graph, one of the projects I worked on, I didn't like get much of the data looking at the map itself. So I had to get an additional data set to kind of correspond with this map to make more sense about it. But it helped a lot converting this into a map form. We have like Box Plus, which we mostly use in exploratory data analysis or EDA, kind of having quartiles of the data where you have like a median, the range, and you can see outliers if you have any outliers, and also a simple time series. They have data points across time. More advanced data forms coming clustering, where you group different data points together that have like similar properties. And also you can note some outliers in the data set if you have any, and with social media now, network graphs is very popular. So you can see all the pairwise relations between different data points in network graphs, and like as we move as technology evolves and we get more advanced in techniques in data visualization, people like combining techniques or coming up with new techniques. So a new technique was combining these two together. So this is it looks nice, and like it tells you something that this is a network relation graph alongside a clustering map. So what it does is it does a pairwise relation between these two, and also clusters groups, so you can get a sense of data. This is my LinkedIn account. Basically kind of networking, graphing it, and creating clusters based on different interests of groups we have. And that's and then finally we have dashboards, which basically kind of put everything together. All the visuals you want to use in your analysis that kind of make sense of the data set. So these are two examples in two projects I have. So this kind of shows you a map and a geo map and some a kind of timeline with also bubble maps, and also just a general bubble map here. So again, having a dashboard gets the user more interactive with the data set. These are all interactive. So clicking on each bubble this is not static. You click on the bubble, you can look at what the data says. You can go look at the underlying data. Similar thing here. You can simply just filter in certain attributes you want to focus on, and again, it's all interactive and it changes with whatever the user wants to look at. So